Problem 6-129. Write three different but equivalent expressions for each of the following logs. For example, log of 7 to the power of 3 halves can be written as 3 halves times the log of 7. Or it can be written as 1/2 times the log of 7 to the 3rd power, or 3 times the log of the square root of 7. All of those would be considered equivalent. So we're going to write three different for each of these. So the first one, we have log of 8 to the 2/3 power. So the first thing we can do here is we could actually look at using the power property of logarithms and taking this exponent and moving it out in front. So that would be the same thing as 2/3 times the log of 8. That would be one option. We could also take it here, instead of doing both the 2 and the 3, moving that whole fraction out there, we can break it up. We could say, all right, well, let's treat the 2 only as it was an exponent. So our coefficient would become 2 times the log, or 2 log of 8 to the power of 1/3, which is the same thing then as like the cube root of 8. That'd be a second possibility. A third possibility that we could end up using for that first one is you could flip-flop your 2 and your 1/3. You could say 1/3 times log of 8 to the 2nd power. All I did was took my 2, moved it back to the exponent, took my 1/3, put it out in front. Now, if you wanted to check to see if what you came up with was correct, what you'll want to do here is get out your calculator and just type in those expressions. So let's look here. Log of 8 raised to the power of 2/3. So log of 8 raised to the power of 2/3. And we will say enter. It's approximately 0.6020 there. Let's just plug in a couple of these other ones just to see. So let's do alpha y equals, we'll just put in our fraction here. So we've got 2/3. And we're doing that times the log of 8. We hit enter, and you'll see we're still at the same value. Same thing here, 2 times the log of 8 to the power of 1/3. And you can just do 1 divided by 3. I just wanted to show, just in case somebody doesn't know how to create fractions on their calculator. So let's see here, do we get the same thing? Yes, we do. And then the last one, we'll just check it also. So we've got alpha y equals, let's put in our fraction. It's got 1/3 times the log of 8 squared. Oh, don't want to mess up now. Let's see, delete. And enter, and you'll see every one of those has the same value, so they are all equivalent there. Looking at the second one now, you have -2 times the log of 5. So we're going to need to come up with some different expressions here. So -2 could end up being our exponent on our 5. So the first one we could have is the log of 5 to the -2nd power. That would be perfectly equivalent. Now say you wanted to bring just the 2 and not the negative, you could say negative log of 5 to the +2nd. That's a second possibility. And then we could also do, let's see here, if we have 5 to the -2nd power, we could rewrite that also as log of 5 to the, well, negative second is going to be 1 over 5 squared, or 1 over 25. So that's another possibility. That's 3. There's several more that you could build off of right there with this one. And let's look at the last one here. So let me just clear this out, just because I accidentally wrote on it there. All right, so now we have log of NA to the BO. So obviously the first one that a lot of people like to jump out there, let's take our exponent, move it out in front, and we have baloney. So we have BO times the log of NA. You could, instead of taking B and O out in front, you could do just one at a time. You could say B times the log of NA raised to the power of O. And you could also do something like, well, let's just do this. We could just flip-flop our letters. Instead of leaving O there and moving B in front, we could do O times our log of NA raised to the power of B. If you really, really want to check them there, if you're not sure, you would probably want to put in values for all of your different variables and see if it works out. In this case here, you've got 3 pretty solid examples for just changing the form of this. These are still equivalent. They still have the same value. They just look different. That is problem 6-129. If you have additional questions, make sure you ask your teacher. Otherwise, thanks for watching.